Hi everyone, thanks for joining my session today, and in the next 45 minutes we're gonna talk about networking and then especially look at how you can do networking on the Azure Platform as a Service offerings. So before we begin, let's thank our sponsors for sponsoring today. That's what makes these events possible. So my name is Erwin. I'm an Azure architect and a DevOps consultant from the Netherlands. I live in a place called Assen, and I work for a company as a consultant, which is called VNet. We do consultancy on Microsoft stuff, so that means on Azure, C#, for example, but also Azure DevOps. So before we dive into the details of networking, we probably should talk first about why you should actually care. Why should you spend your time on implementing the networking features we're going to talk about today? So probably the most obvious reason here is security. Introducing these networking features is one way to lock down access to your sensitive data. Another reason, which is one of the reasons why I got into the field and had to implement networking stuff at a particular client, is that we wanted to be compliant with a security standard. So the diagram you see here, for example, comes from the PCI DSS security standard. That's the payment card industry standard that you need to be compliant with if you want to do credit card payments, for example. So this is the diagram that comes from the Microsoft documentation on that particular topic. And what you see here is that there's various networking features in place, if you look from the left to the right, that make sure that the data, the sensitive stuff that is stored on the right in SQL and in Key Vault, etc., that's being protected by various layers of networking security. You see different network security groups, etc. There's a web app firewall in front. So there's all kind of layers, all kind of networking stuff happening here to make sure that the crown jewels living in the backend here, backend network, being in a database, being in Key Vault, are kept secure. And if someone would want to gain access to that coming from the internet, there will be various layers that he need to be able to get through to get to the actual data. So the goal for today, in terms of what I'm going to show you and what I'm going to demonstrate, is that we're going to build an infrastructure that you see in this small diagram over here. So you see two web apps. I have a UI and I have a API, and there is a SQL database on the right. So what we're going to do here today is we're going to make sure that the API is the only thing that's allowed to access the SQL database. So you can't access the SQL database anymore from any other service in Azure than the API or over the public internet. And we're then going to do the same thing for the API. We're going to make sure that the API is only reachable from our other web app, the UI, and also no longer from the public internet. So we're going to lock that down as well. And we're going to use various services in Azure, various offerings to get that done. So the first thing we should probably talk about here is virtual networks. That's kind of the basic in networking, of course. So a virtual network allows you to join resources in a group and provide them with private IP addresses within the same range, and that would then allow those resources to communicate with each other over a private IP address instead of going over the public internet. So when you create a virtual network in Azure, you can pick one of these three address ranges to work with, and those are the three well-defined private IP address ranges that we have, and you can pick either one of them especially depending on the size of networking that you need, basically. So the smallest virtual network in Azure that you can create is a /29, and that would give you 3 hosts. Normally that would give you 8 hosts, but the thing is that in Azure, and that is also happening outside of Azure, but especially in Azure, 5 IP addresses in each virtual network are reserved for Azure to do its work. So for example, the first IP address in your range will always be used as the network address. And there's a few being used for DNS, and the last IP address in your range is always being used as the broadcasting address. So when you start designing your networking plan or your IP addresses plan, you need to keep that in mind, that you will always lose. You can't use 5 of the IP addresses that are in your range. So you need to make sure that you calculate with that. So, and when you start designing your IP plan, you need to do that carefully. You don't want to create too much virtual networks, because the more virtual networks you have, the more complex things become. You also want to make sure that you don't make your virtual networks too small, because once you start using your virtual networks and once you start using your subnets, it becomes harder and harder to change those ranges, to make them larger or to shrink them. So it's quite important to upfront think about your networking plan and your IP plan and how you wanna get that built. So what you see in a little diagram here is the virtual network, and within a virtual network we can have subnets. So we can make smaller segments within the virtual network if we want to, and you see the nice NSG icon on top, which means that we can have a network security group attached to our virtual network, and that allows us to set a few rules on traffic that is allowed to go in and go out of that virtual network. Basically a firewall, you could say, which allows you to control a bit of traffic. So let's go into the Azure portal and see what it looks like to configure a virtual network in Azure. Before we do that, I first want to show you what I've already prepared today for the demo. And those are the resources that we're going to use today. So what you see here in the list is that there's already a database created and a SQL server. I already created 2 app services. There's the API and there's the UI. They both have their own app service plans. There's application insights involved. We're not going to use that, but it's here. And also already created the 2 virtual networks that we're going to use today, so that you don't see me clicking around in the portal all the time creating stuff and waiting for stuff to be actually deployed. So the API that we're going to use today is a very simple one. It just returns a list from a database. So it reaches out to the database, grabs all the rows in the table and simply returns that in a list. And the UI does nothing more than showing the list on the page. So this is, both applications are .NET Core, and this is a .NET Core MVC application. And it doesn't do anything more than reach out to the API, grab the list that it gets in a JSON format, and then shows that on the page. Nothing more, nothing less. All right, so let's have a quick look at what a virtual network in Azure actually looks like. What kind of properties does it have? What do you need to set up when you start using that? So one of the important things on a virtual network is obviously the address space. That defines the IP address range that resources within this virtual network later on then can use. You also get to specify its DNS servers. By default, you get the Azure DNS server, but if you want to, you can have your own. And one of the other things here is the subnets. And the subnets are, as I told a few minutes ago, allow you to create smaller sections within your virtual network, which allows you to further split up your traffic, etc. In subnets. By default, subnets, resources in different subnets within the same virtual network can simply talk to each other. But if you want to, you could add a network security group. Another thing we didn't talk about yet is that you also have the option to enable a peering connection between 2 virtual networks if you wanted to. We're not going to do that in this demo, but it's good to know that you can. What that means is that you could create a connection between 2 virtual networks, and that would allow resources from within both virtual networks to talk to each other using their private IP addresses. So there's always ways to connect them to each other and be able to communicate with resources in different virtual networks. All right, that's what we need to address on virtual networks for now. Let's go back to the slides. So the rest of the session will be a step through this infrastructure and see how we can actually lock down the services that are already created in Azure, as you saw a minute ago. We're gonna work from right to left here. So the first thing we're gonna do is we're gonna try to lock down that SQL server and then slowly move on to the API and to the UI. So to lock down the SQL server, we're gonna use a offering in Azure that's called a private endpoint. And a private endpoint allows you to access an Azure Platform as a Service offering over a private connection. So that would give your servers, so for example the SQL server, it would give the SQL server a private IP address from your virtual network, so from your range. And you can then use that private IP to connect to your SQL server. On most of the services that you can use a private endpoint on, we will look at a list in a bit. There's quite a few services that you can use a private endpoint on. On most of those services, you get to choose if you want to use both the public address and the private address. So for SQL, for example, that is true. You can add a private endpoint, so you can have a private IP address on your SQL server, but you can choose to still be able to access that from the public internet as well. If you, for example, create an Azure app configuration, that is not true. If you add a private endpoint to an Azure app configuration, you lose your public IP address right away. So that is something to keep in mind when you start adding private endpoints, and especially when you have something that's already in production, it might limit access to the service right away. So that is something to keep in mind. So when using a private endpoint, then the traffic remains on the Microsoft network instead of going over the public internet, etc. So you get a bit of a shorter line towards the surface, lower latency, etc. It also allows you to integrate with on-premises and peered networks we just talked about. So if you would have a connection from your on-premises data center or your office to your virtual network, you would also be able to reach SQL Server, for example, over the private endpoint connection over the private IP. And the same goes for a peered network. If you have two networks, one contains the SQL Server, and then you would be able to reach that from the other virtual network as long as there's a peering connection between the two. Alright, so here's the list with all the services in Azure that currently support having a private endpoint. As you can see, most of them are already general available in all public regions, etc. One thing I do want to point out here is that I quite often use the Azure Web Apps, the one at the bottom of the list. And the thing there is that you can use private endpoints on an Azure Web App, but you would have to use the premium plan there. So the basic ones, the free ones, the standard ones, all don't work. You would have to go to a premium plan. And that will make it quite an expensive option. So we are later on in this session going to see different ways to lock down your API, for example, using something else than a private endpoint. Because one of the reasons for that is that it's simply a cheaper option. Alright, let's go into the Azure portal and let's see how we can add a private endpoint to our SQL Server to make sure that we then cannot reach that anymore. So we're gonna go to the SQL Server. We're gonna head over to the firewall and virtual network blade over here. And this is where you get to control the firewall of your SQL Server. So the thing we're interested in today here is the deny public network access. And currently we can't set that to yes because setting that to yes would require a private endpoint. So let's add a private endpoint. You would have to go through a wizard to get it done. So let's call that thing SQL private endpoint. And we want to do that in Western Europe. That is especially important here as you remember, we're gonna use the regional VNet integration later on the app service plan. We'll talk about it in a bit, but just keep in mind for now, regions are important here. So it wants you to select a resource type that you want to add the private endpoint to. So in this example, we're going to use SQL-server, and then we're going to pick the networking demo SQL-server here and assign it to that. So then there's a bit of configuration. You need to pick the virtual network that you want to use. So here I'm going to use the virtual network of the API because that's the one that needs to connect to it. And I'm going to put it in the default subnet here. That will make sure that it gets an IP address from this particular range. So the next question that I get here is if I want to integrate with private DNS in Azure. And quite often you want to do that because if you later on want to connect to the SQL server from the API, for example, you still get to do that using the exact same connection string that you use today. You are not going to change your connection string. You cannot change it into the IP address. That simply won't work. You have to use the connection string that you always did. And that is the reason why you need to integrate with a private DNS zone, because already need to integrate with DNS. Because there needs to be a translation between your connection string and the record, the DNS record, to the private IP address that will be assigned to your SQL database. So we're gonna integrate with a private DNS zone, and that's gonna be called private link.database.windows.net, and it's gonna create that for us. So that's it. Let's hit create, and then this stuff is gonna be created. Sometimes it takes a while, sometimes it's done pretty quickly. So let's see how that is gonna go today. So in the meantime, we could go and have a look at the private DNS zone. That one was already created, and we're going to integrate with that private DNS zone. So as you see, currently there isn't a record yet for our SQL server. That will come in a few seconds. What's important here is that if you would start to create these private DNS zones yourself, if you, for example, want to create these DNS zones using ARM templates, then it's important to know that you have to use this specific name for it to work. There's a whole list in the documentation section on the names you need to use for private DNS zones. So if you want to do database DNS integration, you have to use this particular one. There's also a specific one for key vault, a specific one for app configuration, etc., etc. You would have to use that specific name, otherwise it won't work. Alright, so as you can see, the private endpoint got created, and I now do have a record on my private DNS zone that says that the networking demo.database.windows.net should now point to this private IP address instead of to the public one it did before. So that worked, great. That also means that if you now go back to the SQL server and we go back to the private endpoint connections, then you see that there's now a private endpoint connection. And if we then go back to the firewall blade over here, then there's two things we can now do. I can now say, no, I do not want to allow Azure services to access this particular server. We only want stuff to be able to access the SQL server over the private IP, and also want to block the public internet access. So we're going to drop the public IP. We're going to hit save, and then let's see if this actually works. And what should happen now, it sometimes takes a while for the firewall to kick in actually. So you see that now that I start refreshing this particular page, that it doesn't yet throw me an error. It sometimes takes a while, sometimes it's a bit of caching involved, etc. So what we're gonna do here, we're gonna jump back to the slides, and then later on come back here to see that the API is actually not being able anymore to access the SQL server. I'm gonna quickly give it a restart as well to make sure that any caching that might be involved in my app gets deleted. All right, so let's go back to the slides. What we've seen so far is that I can lock down my SQL server that now has a private IP address using a private endpoint, and I've blocked public internet access by switching that setting on the top to yes. So the next thing we want to do is make sure that my API is still able to connect to the SQL database. And to do that, we're going to use something that's called App Service VNet integration. And what that allows you to do is it allows you to let your app server join a virtual network, or actually a subnet within your virtual network. And that subnet will then be used for egress. So the VNet integration only allows you to join a subnet and use that for outgoing traffic. That's important to know. It's only for outgoing traffic. The integration we're going to use today, there's two types of VNet integration. The one we are going to use today allows you to access resources in your VNet within the same region. And that's important. As I mentioned, there's two types of VNet integration. There's a regional one, which we're going to use today, which is the default. But there's also the gateway VNet integration. And the gateway VNet integration would allow you to access resources in a different region. But it's a bit more complex to set up. There's a bit more involved there in configuration. And it's also a bit more expensive. So today we're going to use the regional one. It does, however, on the app service require a standard or premium app service plan. So it doesn't work on a basic one or on the free ones, but at least it does on the standard ones. So you need to be at least on the standard plan. And once you have configured this and your outgoing traffic from your API actually goes through your subnet, you also get to block traffic that's going out of your subnet using a network security group. So you could make sure here that your app service is only able to reach your SQL server and not being able to reach anything else on the public internet, for example. So you could also lock it down, also lock down the outgoing traffic. So let's quickly look at how that VNet integration looks like on the app. Let's first go back to the API and hopefully see that I now get an error, which was quite expected. And it also nicely points me to the fact that the deny public network access is set to yes, and that is the reason that I cannot access the SQL server anymore. So let's fix that. We're gonna go into my API and do a bit of configuration on the app service plan. There's two things we need to do here. First, we're gonna head over to configuration and then head over to the networking configuration. Networking there. And we're gonna enable the VNet integration. So we're gonna click here, and I'm gonna click here to say add VNet. And this is then where I get to pick the VNet integration. So I'm gonna choose my virtual network, and I want to integrate with my API VNet. So I'm gonna pick that here. And as you saw in this drop down, by the way, you also have the difference here again between the same region integration and the other regions integration, which, as mentioned before, then requires a virtual network gateway, etc. So I don't have that, so I don't have any options here, but you also see the difference in the drop down here as well. I now get to pick a subnet to let my app service join with. And as you can see, I can no longer pick the default one. The default one we just used for the SQL server. So one IP address has already been used there. And if you want to have a web app join a subnet, then that needs to be a subnet that doesn't have anything else in it. And that's because what happens here is that you could kind of say that this subnet will be given to your app service, as in here app service uses VNet. We call that delegation, and that means that only your app service can use the particular subnet and nothing else can use it because it has been delegated to the app service. So let's do that. Let's do the integration. So, and that's done. You can see that it's been integrated with the virtual network and it's been integrated with the particular subnet. That's one of the things we need to do. So we've now done that part of the integration. The other thing we need to do is that we need to set two configuration settings on the app service. The first one being website DNS server. We need to tell it which DNS server to use in order to reach the private DNS zone that we created earlier and which contains the record to our SQL server. So you need to point that to this particular IP address, and this is a hard-coded IP address. This IP address will never change. You can find this one in the documentation on the Microsoft documentation pages. So you can use this IP address to reach the private DNS zones. The other one is that we need to set the website VNet root all to 1. And that will make sure that not only private traffic, but all traffic that goes out of your app service will actually go through your VNet. And that's what we need in this particular example. So I've already set these two values. You probably don't want to see me typing all the time. So that means that if stuff actually got nicely in place, you see that we now again are able to reach the API because we've done VNet integration and it's capable of reaching the SQL server over its private address. So that's great. All right, let's go back to the slides. So what you've seen so far is locking down the SQL server and then making sure that the API can still reach that SQL server using the VNet integration. So traffic now flows through the virtual network, and that's why we can still access the database, and only our API can access that particular database. The next step here in our little infrastructure is to make sure that now our UI is the only thing that could reach the API. To do that, we need to actually do two things. We need to make sure that the UI uses its virtual network to go to the API, and then we need to make sure that the API only allows traffic from the UI. So there's two steps involved here. The first one, making sure that the app service uses its private network to go to the app service, is using what's called a private endpoint. And what a private endpoint does, it provides a secure and direct connection to an Azure service. And so that means that traffic that comes from your Azure service stays on the Microsoft network instead of going over the public internet. And because of that, because the traffic now flows over the private connection over the service endpoint, we can then, on the other side of the connection, lock down that traffic to only allow specific traffic, as we will see in a bit. So what actually happens under the hood here is that if you add a service endpoint to a particular service in Azure, and we will look at a list of available services in a bit, what happens then is that a new row gets added to its effective route tables. So this is the route table of a virtual machine in Azure. If you just create a virtual machine, look at the effective routes that it has, so the ways to communicate with anything else, then this is what you get. The only thing that got added here is the blue row, and that one got added because I've added the service endpoint to my VM, and I've added a service endpoint that points to SQL Server in this particular case. So what you see here is that a new row gets added, which has a lot of addresses defined in the address prefixes column. And all of those addresses there, the 48 addresses that are defined there, are all the private IP addresses within Azure that are available to connect to a SQL Server. So that's kind of how that works. A route gets added to the route table of your Azure service, and because it's there, it knows that it now can privately connect to another Azure service instead of going over the public connection. So a service endpoint is already available on quite a lot of services as well. We talked about connecting to SQL mainly here, and we're also going to use that to connect to the app service, but it's available on quite a lot of different other services as well. So the second thing we need here to lock down the API is what's called an access restriction on a web app. So to summarize that, you're going to use the private endpoint on the UI to go to the API over the service endpoint and use the private addresses. Then on the web app, we can use access restrictions to only make sure that traffic from the UI going over the service endpoint is allowed to access our web app. And that gets done by defining a priority ordered allow deny list that controls the network access to your app. So on the app service plan, you get to say that, for example, only a particular IP address is allowed to reach your app service plan, or what we're gonna do today, you could say that only a particular virtual network is allowed to access your API. So let's go over to the API and start configuring that. So we're here still within the API. We're gonna go again to the networking section here, and then on the bottom of the list there is the access restrictions. So we're gonna hit configure there. And as you can see, by default, you get one rule, and that says allow all. So by default, it doesn't matter where traffic comes from, it's allowed to access your server. So we're gonna add a rule here on the API. We're gonna name the UI, since it's the UI that's gonna be allowed to access my service. And then you get to pick a type. So you could specify an IPv4 address, a V6 address. And what we're gonna do today is we're gonna specify a virtual network that we wanna allow access to our API. So we are now going to pick the UI virtual network, and we're gonna again pick the web app subnet that lives in the network. The other stuff down here is new preview stuff, but we don't need that here in this particular example. So I'm gonna hit add, and as you can see, my row got added to the list, and there's now also a deny all rule. So instead of an allow all rule, we now have deny all, which means that if traffic doesn't come from this particular subnet, it's now going to fall down to this particular rule and be denied. So you won't be gaining access anymore. So you can see there's actually two types of lists here. And this one, the second one is the address of the management side of your app service. So if you ever used Kudo on your app service, for example, then this is the address that you use to reach that management plane on your app service. And you also get to assign rules there as well, or you could say that you want to use the same restrictions as on your website itself. So what you, for example, could do is that you might want to make your API available just from your UI, but you might want to add your office IP address here, for example, to still be able to reach the management side of things from your office IP, or since everyone's working home today, from these times, from your home IP, for example. So you could add that here as well. If you start doing that, however, you need to be aware of the fact that if you use, for example, Azure DevOps to deploy your app service to this app service plan, then also Azure DevOps wouldn't be allowed anymore to access your management side of your app service and be able to do a deployment. So there's a few options to get around that. There's actually a bit of documentation which contains all the IP addresses that Azure DevOps could be using to deploy anything to your service. But that's a huge list, and it could potentially change every 2 weeks. So you could use that and probably write a bit of automation around that to make it work, but that probably doesn't work too well. So the easiest option here is to create your own private agents, and then have them have a private IP and then allow those private IPs in this particular list. So that's probably the easiest option to go for if you want to lock down the management side of things as well. Alright, now that we've done that, we've locked down the stuff over here. If we then go to the API and I refresh it, I'm gonna get a 403 because the IP I'm now using to reach the site, my home IP, isn't allowed in that list, so I'm gonna get a forbidden. The same is gonna happen on the UI. because we have already allowed the VNet of the UI to access the server, but our UI hasn't yet joined that particular VNet. So that's why it's getting a forbidden error now. So let's fix that by going into the UI, again going into the networking section, and again going to the VNet integration, and then let's hit add again. We're gonna pick the UI this time, and we're gonna integrate that with the web app one. It takes a little while to add it there. All right, and one thing to notice here is that if we go to that particular subnet, that you now see that on this particular subnet, there's a section called service endpoints. And as you can see, here's the list of services that you can use a service endpoints towards from your app service. And Microsoft.web has already been enabled. I did that up front because it sometimes takes a while for that to become effective. It might take up to 15 minutes, half an hour. So I did that up front. If I wouldn't have done that yet, then I would have gotten a warning while configuring this that I would need to set it up, and the portal would actually automatically do that for me. But here it's already been done to speed up this demo. Alright, so if I now go back here, we should actually be able to refresh this particular page, and then we should actually see the whole list again coming from the API. So that now also nicely works, because we've been integrating that UI again with the network, and that particular network has been gained access to the app service API. Alright, let's go back to the slides, because there might actually be one question that you might be having now, and that is, when I start locking down my services, so you've seen me lock down my API, you've seen me lock down the SQL database, you probably still want to be able to gain access to both services from your office, from your home, to be able to actually get your work done, because you simply need to gain access to those services. So a way to do that is to make sure that you use a VPN connection to be able to get into those same virtual networks in Azure as where those services live. And there's various ways to get that done. And we're going to talk about a few options here to give you an idea what options you have to set that up. So the first option you have is that you could set up what's called a VPN gateway, VPN connection between, for example, an on-premise location and a virtual network within Azure, and that would then use a VPN private tunnel to gain access to the virtual network, and you would then be able to reach services within that virtual network or any of the paired virtual networks for that matter. So that one was actually called a site-to-site VPN connection. There's also the multi-site option, as you see in this little diagram over here. There's simply another office being added, and there's a second connection into the same VPN gateway. So that's an option as well. You could also use these VPN gateways to connect two Azure regions with each other. So if we, for example, would do that VNet integration on the app service, but then want to reach a SQL database in another region, then this might be the right way to go. Set up a private connection between the two Azure regions, and have a private connection between the two and send your traffic over the VPN gateways. Another option that you have is use the express route. That's a very expensive connection from your on-premises location, your on-premise office, your on-premise data center into the Azure data centers. That's often used as the primary connection in large enterprises because it gives you a private connection, more stable, more reliable, less latency, etc. And you can actually use both gateways at the same time in a fallback scenario. So you could have the express route gateway be connected to a VNet, and also have a VPN gateway connected to that VNet. And then you would have a private connection both over private endpoint and a private connection using VPN towards your virtual network in the Azure data center. So both options are available, and you could then configure what should be your private route. So probably the easiest, at least if you don't have too many users, probably the easiest way to set up VPN is use the point-to-site VPN connection type. That's also available. And what that means is that your clients will just use their devices to directly call into that VPN gateway. So in all the other examples that we've seen earlier, you would have a device in your on-premises location that would set up the VPN connection to Azure. In the point-to-site VPN connection example, you would just install a piece of software on your device and make sure that that enables you to use a private channel into Azure. And there's a few ways to authenticate on that connection. So you could use a certificate, for example. You could authenticate using your Azure AD accounts. Radius is an option, or use OpenVPN. And it depends a bit on your devices mainly, which of these options are available for you to use. So it depends a bit on if you have mobile devices or not, and it depends on the operating systems being used on PCs, etc. But these are the options that are available to you. So another option is, besides the Azure built-in stuff we just talked about, another option is to use a third-party solution. And that's what we went for at one of my customers recently. So we picked a solution by Cato Networks. What Cato gives us is a VPN connection, a point-to-site VPN connection into our Azure data center, our Azure virtual networks. And one of the benefits here of using Cato is that Cato has what is called point of presence around the world. There's around 50 of them. And what that means is that when you start setting up and creating a VPN connection, you won't use the public internet to go into your Azure virtual network. You would actually connect to the nearest point of presence from Cato, then go on their private backbone, and from there on connect through their private backbone into your Azure data center. So that gives you again a more reliable, stable, faster, more secure connection into the Azure data center, simply because there's less public internet involved. Another thing that we also got by using their systems, using their offering, is that once traffic through the VPN and other traffic as well comes into the Azure data center, it first goes through what is called a next generation firewall. And that's basically a virtual machine which runs firewalling software. And that firewalling software does deep packet inspection on what goes over the line and is that even secure. So it's a firewall that goes a bit further than just denying traffic based on an IP address or a packet type or whatever. It actually does inspection of the traffic. What you also get from going with one of these third-party options is much more availability on how to configure your connections and configure what traffic should go over the VPN and what traffic should not, and all of those things. So you get nice dashboarding in which you can see what's going on, and you get full monitoring on connections and see why someone is being able to connect into Azure or someone might not be able to connect, stuff like that. So it goes much further than what you would get out of the box on Azure, but of course that comes at a price. So we're almost near the end of my session. This was what I wanted to share with you today. So let's once more thank our sponsors for making the event here possible. I hope you learned from my session. I hope you learned from all the other sessions that you've seen today. If you want to reach out to ask questions about the session, please do. This is my Twitter handle. You can always find me there. I also have a blog, erwinstaal.nl. And there's, for example, a blog post there on how to set up the integration between the API and the SQL server. you can find there how to do that. It even includes ARM templates, etc. So with that, thanks for joining my session and have a nice day.